Just a short introduction. Welcome to today's Open Operations Meetup. Today topic will be Kubernetes as a service. As you all might know, Kubernetes as a service is a central component of the sovereign cloud stack. And in SCS, it's driven as the Cluster Stacks project. And the topic today is developing and deploying SCS Cluster Stacks. And we have for the first part, Yannis from SciSelf for the development part, and for the deployment and production or operations part, Roman from DNation. And they will split the talk and show you the theory and the practice. And yes, then I hand over to you, Yannis. Thank you.
Cool. So as Dominic said, this is about the Kubernetes layer of the sovereign cloud stack. And there we build a framework called Cluster Stacks. And that's what we're going to talk about today. So today's talk is a mixture of, the sovereign cloud stack. Dominic just started. Of me, I'm the founder of SciSelf, and of Roman, who works for DNation. So these are the three logos that you see there. Okay, coming to the agenda. I'm going to start with the reason why we have these cluster stacks. I continue with why they exist and what they are. And talk about certain use cases that you, if you want to use them, if you want to run them on your own infrastructure, then we'll talk about what you can do there. Roman will have a demo of the whole thing, and we'll of course have some Q&A at the end. But also, if you have any questions in the meantime, then just really feel free to just ask. Okay, so why cluster stacks? What we wanted to do with the cluster stacks, or what we wanted to achieve, was we wanted to build a Kubernetes as a service solution. And there are a lot of things that have to be done. You see some of the things there. So it starts with that a cluster consists of a lot of configuration. And there we can kind of go through all the layers. So it starts maybe with node images, and it ends with applications that are in your workload clusters. All of this configuration has to be obviously tested. If you tested it extensively, you can package it, you can distribute it to your users, and then they can use that. So all of that has to be done. The cluster lifecycle is important in the sense that you need to be able to create clusters, like your nodes have to provision, and all of that. Okay, so the prime thing here is going to be Cluster API. However, Cluster API is responsible only for the cluster lifecycle. So actually, lots of people kind of consider Cluster API to be the turnkey solution to all of your problems related to managing Kubernetes, but it is certainly not. It's like one component. It's a great component. But as you see there are lots of things which Cluster API still does not take care of. And we wanted to solve this problem, and we wanted to make it easier to run a Kubernetes as a service solution, a Kubernetes platform on your own. And we created the Cluster Stack framework for it. Looking at all of these things there, like development, maintainability, configuration, testing, versioning, packaging, it's all very generic. So there is no kind of solution like one fits all. So that was the idea, to create instead a framework where you still have all the flexibility that you need. However, at the same time, the framework facilitates a lot of things for you. So this is kind of the idea behind the cluster stacks. So what are they? First of all, which goals do we want to achieve? There are two sides. First of all, there is the operations. So if you have a Kubernetes as a service solution, it's obviously way more than just creating one cluster. So you want to create a lot of clusters. You want it to be scalable in that way. At the same time, you want the operations to be user-friendly in the sense that you can just create your clusters and very easily. You can create the clusters very easily. You can maybe update them very easily. So all of this is part of the operations. And this is what we wanted to achieve there. The second thing, scalability, I already mentioned. Like, we want to have a solution that is actually scalable so that you can create pretty much as many clusters as you want. And these clusters, these operations have to be reproducible, in the sense that, like, you shouldn't in the end think about, okay, like, how does this cluster look? How does that cluster look? How does that cluster look? Like, in the end, you want your clusters to look rather similar. You should know what there is inside. And this is what we wanted to achieve also with the operations. On the clusters, we want the clusters to be ready to use. That's a very important topic, because for the people who have tried out Cluster API already, they know that you have to install certain applications into your clusters, into the workload clusters, in order for them to be usable. So namely, for example, the Cloud Controller Manager. So this is actually what we also wanted to kind of include in the framework. So we need to have a look at applications in the workload clusters. The second thing is that we wanted this to be production ready. Like, it's a framework, so we cannot really say it's production ready, of course, like beforehand. However, we wanted to achieve something that can be used in a production ready way. One of the things that we personally, or that I personally think is very important, is that you include node images in, like, your thoughts, kind of, that you can build your own node images. This is important for production readiness, because otherwise, like, you can't control them, obviously. So our framework includes the node images inside. Then the clusters, last thing, obviously should be reliable. So you want to be able to build something which is actually reliable to the users. Okay, so these are the goals. Very important. They are separated into stuff which is like on cluster level, like individual clusters, but also especially on the operations side, that you are able to create something which is as scalable as you want. Okay, let's come to what the framework consists of. On the left-hand side, you have the cluster templates. Actually, Cluster Stack is a name, like a stack of components of a cluster. So this is where the Cluster Stack, like, name comes from. So you have stacks of components of a cluster, you build them, and then you need to obviously ship them. And this is where the tools come into play. So first of all, you have the Cluster Stack operator, which is a tool that ships the cluster stacks to your users and allows them to use them very easily. So this is what the Cluster Stack operator does. There's a CLI tool as well, which kind of facilitates building these cluster stacks. So we have, like, obviously a division between using them or using the Kubernetes as a service solution and actually maintaining or building it. So this is where the CS Cluster comes into play. And then, very important, just as Cluster API can be used to with any infrastructure, you have to obviously make or build a provider integration for that. The Cluster Stack framework works in a similar way. So you can have a provider integration there of the Cluster Stack operator, and then you can use this on any infrastructure. So right now there are just like lots of logos, but they are just examples. Right now, for example, we internally at SciSelf have something for Hetzner. There is the SCS OpenStack solution, which we are going to see later also from Roman. And you can use it for any other infrastructure where you can already use the Cluster API. Okay, that's the framework. So let's look a bit closer to the bundles of configuration, so the stacks of the components. We consider the stack to be on like 3 layers. The base layer, I've mentioned it already, are the node images. So a cluster stack, one of the components is like the definition of the node images. Then on the second layer, you have the Kubernetes configuration. So for example, for the people who know that, like related to kubeadm. And on the top layer, you have the cluster add-ons. This is actually like about the applications which are installed into the workload cluster. So let's have a look again at the tools from before. The node images are very provider dependent. So for example, on one provider, you need to do a certain action in order to kind of ship your custom node images to the users. In the other provider, you might have to do something else. So node images are very provider dependent. So this is actually what the provider integrations of the cluster stack operator do for you. So the provider integrations, if you have like a certain use case where you need to do something with your node images, which can be automated, then this would be part of the provider integration, for example. Then on the second layer, the Kubernetes configuration, this is what has to go into the management cluster. So for everyone who doesn't know it, Cluster API has like a management cluster. And from this management cluster, you kind of control all of your workload clusters, which are the actual Kubernetes clusters that you then in the end work with and use. So the second layer of configuration gets into the workload cluster, or has to go into the workload cluster. And this is what the cluster stack operator does for you. So you tell the cluster stack operator, okay, give me this, and then it will take care of that. The third layer about the cluster add-ons is also interesting because the cluster add-ons, aka the applications that have to go into the workload clusters, have to go into every workload cluster. So you have like one management cluster, but you might have whatever 200 workload clusters. So these cluster add-ons go automatically into and get installed automatically in each workload cluster. This whole thing works also with updates. So you see there one bundle in the version 1 and one bundle in the version 2. That's just an example, of course. But you can obviously upgrade the whole thing, the whole stack from the version 1 to the version 2. The development cycle, like how does it look like? So I just want to kind of summarize it again. I've talked about like most of these steps. So the first step is that you build one of these stacks. So if you have built it, you can test it. If you have tested everything, like all the components together, the whole stack, then you can release it. And you actually release the whole stack, like you release the node images configuration together with the applications that go into your cluster. The advantage there is that you can be sure that everything works together. And there is like no room for any like small details that change from one cluster to another. No, like if you create these bundles, you can create clusters based on them, and they always look exactly the same. Sorry. Okay, so after releasing it, so for example, we have our cluster stack in the version 1 is now released, then we can use it. And actually, that step of using it is very easy. You can basically, in an automated way, ship it to all of your users. They all get access to it at the same time. They obviously need to get notified in some way. But if they are notified, they know, okay, there is a new version of it, so I'm able to use it. And then they can create clusters based on them. They can upgrade existing clusters to that new cluster stack that you released. And yeah, that's the development cycle. Use cases for operators. One use case, or like there are basically two use cases which are rather similar, but there are maybe certain advantages which yeah, are slightly different, or like where you want to look at differently. First of all, this you can build an internal Kubernetes platform with this. In the way that, for example, like if you have a really large use case and you want to build this on your own, you can build clusters that always look the same. Like the advantage there is obviously if you have a team and they like work on certain applications, and then if your clusters look slightly different, like you might get into weird, like run into weird problems that like are based on the fact that your clusters did not look like exactly the same. So actually here you get reproducible clusters. So that's like something which is quite important for an internal platform, especially. Second thing is your clusters are ready to use. Like this is also obviously a good thing if you want to sell them, but like for internal use cases where your people should focus on building the software or running it, it's important that they don't have to worry about managing the Kubernetes clusters. So they get clusters that are ready to use, and they can directly go ahead and yeah, use them. Okay, the second thing that you can also do, I know that there are some people that are also into like the cloud business and that maybe offer certain solutions here. You can use this approach, this framework, in order to build your own managed Kubernetes. The advantages that you have, for example, is that the whole thing is scalable, so you can just kind of create as many classes as you want. It's like very easy. For example, if you give each of your customers one namespace of the management cluster, you can scale that very easily. And also your clusters have your customers have a very scalable approach. And your customers obviously profit from the user-friendly operations that there are. So if you think about building your own managed Kubernetes solution, which is surely not the easiest thing, I can say that from experience, then you might consider this framework. Just coming shortly back to the personas of like working with the cluster stack to make it also clearer in the next step, because we're going to approach soon the step when Roman is going to show the live demo. There's first of all the user of a cluster stack. So the user would, for example, get a namespace of the management cluster and then create clusters. These clusters can be created very easily. You can create as many as you want, obviously, and that's like kind of what the user does. The developer, on the other hand, in this case, is a developer of cluster stacks. So he's the person who is actually responsible to manage the Kubernetes solution. So to manage the configuration, to build it, to test it, to release it. So this is these are the two personas kind of interacting with that. So there are two steps when you want to use a cluster stack. Here's an example of one YAML file. So this is now going to be a bit more technical, but we are also going to see that later. Here an example based on the Docker provider, which is like an example provider that you can kind of try it out with very easily. However, it always looks the same. So this is why we are going to show it with Docker now. So basically, you have the cluster stack custom resource. This cluster stack custom resource is something that you apply once and then kind of pretty much never have to look again. So we see in like 9, line 9 that we have the Kubernetes version, actually very outdated. Should have updated that. 1.27. This Kubernetes version is fixed, but then later you can always upgrade it, obviously, to other Kubernetes versions. But essentially, you have this one object per Kubernetes version. And then if you want to update it, if you want to update to a newer version of that one cluster stack, you kind of, through this one object, get these updates automatically. Like you don't kind of update your clusters automatically in a way that you don't want it to be updated, but you have the option of updating it. So this is like a very easy thing, and it's controlled in the cluster object. It's the Cluster API cluster object here in line 14. So there you refer to one cluster stack. Here, the Kubernetes version 127 on the provider Docker in version 1. And then you get your cluster created based on this bundle of configuration that you have there. And your cluster gets created with all of these bundles. So including node images, including applications in the cluster, all of that together gets created automatically. So this cluster object is the one thing that you need to do, the one YAML thing that you need to apply, obviously after you applied this thing here. And then you can get started and use it. And that's kind of the same as you need to do, like if you create like 5 clusters, you just have 5 of these objects. Very interesting for the people who want to use GitOps, because you work in a declarative way here with this YAML file. You can natively use a GitOps approach, for example, to manage your clusters here. Okay, so that much about the like theoretical part. I would ask you whether you have any questions so far, because otherwise we'll go ahead to the live demo.
Okay. Thank you, Yanis. So hello again. Here, Roman from D Nation. I will show you the live demo about the OpenStack specific cluster stacks deployment. So I will create and later upgrade the cluster created via this cluster stacks framework. And I will describe some YAML files, some custom resources in the management Kubernetes cluster, and so on. And at the end, there will be space for the questions. Okay, so let me share you my screen. Can you see my terminal and something?
We can see it, yes.
Yes.
Oh, thank you. Okay. So basically, as Yanni said, in the cluster API world, you need the management cluster. Right now, on my local machine, I'm using Kind, Kubernetes in Docker, local Kubernetes installation. So I have all the pods running, all the system and Kubernetes core pods are running. And also in this cluster, I have installed the CAPI and CAPO controllers, so Cluster API and Cluster API provider OpenStack operators. And also, what is more important, there are these two pods, like Cluster Stack operator and Cluster Stack provider OpenStack operator. These two controllers will control the custom resources. Also, what Yannis said about cluster stacks and so on. So let's go into it. You can see this YAML file here. I will show you the OpenStack specific cluster stack. Yannis show you the Docker one. I will try to create the cluster on the OpenStack infrastructure. So basically, I have this YAML file. You can see I'm using the OpenStack provider here in cluster stack. Cluster stacks have also names. I'm using Kubernetes version 128, and also I am referencing the provider stuff here. Because we are on OpenStack, we need the provider specific templates. Right now, this template looks like this. So basically, I'm referencing only OpenStack secret here. Inside the secret is there are credentials necessary for the accessing the OpenStack, and also the CSPO or Cluster Stack Provider OpenStack operator will use these credentials for managing the images or node images necessary as the first layer in the cluster stack necessary for the spawning the workload cluster later. So I already applied this file into this management cluster, and we can check the cluster stack. It has CSK short name. I have dedicated namespace also, and you can see I have one cluster stack here with version v2, which is usable. We can go also a little bit deeper. So when you apply this cluster stack, the cluster stack operator creates a resource called cluster stack release. And you can see that cluster stack operator creates one cluster stack release per version. So I have one version, only v2. So I have one cluster stack release here with desired Kubernetes version. And when we are using OpenStack provider right now, so there are other resources like OpenStack cluster stack release. It's also ready, and also node images have specific custom resource in this management cluster called OpenStack node image releases. You can see I have one image which is ready. It means that cluster stack provider OpenStack successfully uploaded it into the OpenStack image service, namely Glance. Okay, so when I have everything ready. So namely, this cluster stack release is ready. I can continue with creation of the workload cluster. So I have this second YAML file cluster. This is cluster API specific object. It's pretty simple spec here, some IP ranges for pods and services. But what is more important is this class and this version. You can see that I'm specifying this cluster stack release and this Kubernetes version, because it's only this is usable right now. Later we will upgrade to the newer version and new Kubernetes version, hopefully. Okay, then I have some variables here. I will go back to them later. And I have control plane spec here. I want 3 replicas, and also I want 3 replicas of the default worker nodes. This class is also part of the cluster stack release. Okay, I can apply this file, and yeah, CS cluster. This is the name of this cluster object is created. Cluster API has tool called cluster cattle, and we can use it to describe cluster in namespace, and we can see that cluster is preparing, so some scaling up and waiting for available machines statuses we can see here, but we already see that one machine is ready. We can also check the underlying OpenStack infrastructure here. So some OpenStack server list can do it. Yeah, and we can see that one node is already active, and using this Ubuntu copy image 128 here. Okay, let's see if there is a progress. Okay, we can wait a little bit, and I will describe these variables. Okay, so these variables are used to customize this cluster stack. So basically, a developer of the cluster stack can define these variables, and then user can use it to customize his workload clusters. So basically, right now I'm defining flavor. This is the how much CPU and RAM I want for the controller nodes, worker nodes. There are some other possibilities here. For example, I am defining SSH key. So each instance or each VM will get SSH access here with the public key called test. Okay, some ID of the external network, and also I'm using cloud, which OpenStack Cloud, which do not have load balancer as a service, namely Octavia. So I am using right now kubevip, this nice project which ensures the load balancing without some physical load balancer. So I'm defining some necessary variables for the kubevip here, IP addresses and network IDs. And also I'm specifying that I do not want workload load balancer right now to be deployed. But for example, you can use YAML as an example, and here are some mandatory variables for the YAML workload load balancer. So for me, there will be no controller which handles the Kubernetes services of type load balancer here. But for the demo purposes, it's enough, I think. Okay, so we can check. Yeah, it's still scaling up, but we can see that 2 control planes are ready. So we can probably get the kubeconfig. So again, use the cluster cattle tool, and let's save it into the kubeconfig.yaml. We can export kubeconfig. let's get nodes. Yeah, and you can see that already 5 nodes are here, 2 control plane nodes and 3 worker nodes with the desired Kubernetes version. You can see some other spec of the image. And okay, yeah, workers are ready and control planes are still joining, but cluster is functional, I think. Let's see the pods. Yeah, okay, and all the pods are running. So basically we have some core Kubernetes components like kube control manager, kubeproxy. These are installed by kubeadm. But what Cluster Stack does, it's the third layer called cluster add-ons. In this case, in this OpenStack Cluster Stack, we have Cilium CNI installed via Cluster Stack. We have a metric server here. We have OpenStack Cinder CSI as a cluster add-on, and we have also OpenStack Cloud Controller Manager. So, yeah, and we can see that all the nodes are ready because we wanted 3 replicas of each. Okay, yeah, and about cluster add-ons, these cluster add-ons are also represented in the management cluster by custom resource called cluster add-on. So we can check if it's ready. Yeah, and it's ready too. Okay, we can proceed with upgrading. Upgrading is very simple. So basically, you have 2 options. You can deploy cluster stack with auto subscribe true. Then cluster stack operator will automatically download latest versions. But for this demo, I will do it manually. So I will add the next version of this cluster stack provider OpenStack, and I will apply this cluster stack. It's configured, and when we get, yeah, we can see that one is ready, and with free version with new Kubernetes version is false, but it's waiting for the provider cluster stack release. So we can check the OpenStack cluster stack release resource. There is ongoing process, so we have to wait a few seconds. So the operator cluster stack provider OpenStack operator can ensure the images in your cloud, in your OpenStack cloud. Yeah, and it's true. So also the cluster stack release is true, and we can use it. So basically, it's very easy. Just change these 2 fields, like v3 here and Kubernetes version increase. Okay, when we apply the cluster, describe via cluster cutoff tool, we can see that rolling update is in progress. And this rolling update ensures that all nodes will be replaced by new nodes with new Kubernetes version, in this case 1.18.13, and we can probably check again the infrastructure if it's, yeah, and we can see already that we have 1 node with new image here ready to be joined into the workload cluster. And okay, let's export kubeconfig of the workload cluster. Yeah, and already joined the cluster, but still not ready. But the rolling update will update all the nodes. Also, the cluster add-on will be upgraded, and in the few minutes, the whole cluster will be upgraded. We can check the pods. Yeah, you can see some container creating here and here. And when it will be done, probably the node will be ready. Yeah, this is the rolling update process. So old node will be drained, and then will be replaced with the new one, with new Kubernetes version. Okay, and what we can do next is, for example, we want to customize worker nodes. So right now we have 3 worker nodes which are all the same. Yeah, 3 replicas, some default worker nodes, and we specified also flavor. So each worker node has same flavor. But for example, what if someone wants one worker node bigger than others? So we can specify this one. So basically, we create a second machine deployment. We can call it like big worker, and with 1 replica. And you can see that we can easily override variables here. So I am overriding the flavor, the root disk, also SSH key. And when I apply, then I should end up with another worker which has more CPU and RAM. Here you can describe. Yeah, you can see that we have 2 machine deployments, big worker and default worker. The rolling update is still in progress, so two processes are currently running. Yeah, we can wait, and we should end up with we can see that the 1 control plane node was replaced with new version, and the rolling update will do all the things next. Okay, so that's it. Now we can continue with questions, I think, and then we can maybe go back and check if it's all done. But that's it for me. Thank you.
Thank you very much, Roman. I have one comment on that, but I would first ask whether anyone has questions. Quote.
Yes. First of all, thanks a lot, Roman and Yanis, for this nice presentation and the nice work that's behind that. Yanis, a question to you. I think you mentioned that in order to create a managed Kubernetes solution, you could create this management cluster and then hand out namespaces inside that cluster to different customers, and then they could apply the cluster classes or the cluster stacks in there in order to manage their own workload clusters. So I do know we've had discussions with some people that are very security sensitive, who do not want to have a shared management cluster. And I know we've been working with the Kamachi folks on an alternative path for those. Can you quickly comment how that works and where we are on that trip?
You mean for alternatives to a shared management cluster?
Yeah, maybe using technologies like Kamachi. Yeah.
Actually, I was not really involved in the work with Kamachi, so there I would ask Jan for a comment. What I can say, so as a disclaimer, my company has like a Kubernetes platform running in production based on this technology. And what we do for certain clients is that they get the full management cluster in their infrastructure. So this is obviously not kind of the most efficient solution in the sense that obviously a management cluster also like takes certain resources. However, this is probably the most secure thing that you can ever do, because the management cluster can run on the customer's infrastructure fully. So like with regards to people who really look for a solution where this is like fully isolated, I would actually say that that might be a good option. So how this works in theory is that you just need to take care of that the management cluster can be like started and maintained on like different infrastructure. So this is actually what you need to do. Other than that, like these cluster stacks, for example, like they come from a central place. So if you, for example, ship an update of these cluster stacks, you can ship that also to like N management clusters. So in theory, like if all people want to have a separate management environment, this would still not affect kind of stuff like scalability, for example. However, I know that this is like a very different approach than what Kamaji would do. So if you want to like stress that, Kurt, then I would actually ask Jan to say something about that.
Yeah. Just before Jan takes over, just maybe a quick comment. I mean, obviously, having a management cluster per customer is always a possibility, and I mean, in the end, it's also just small virtual machines inside your cloud, so it's not that huge. But I mean, we've had the feedback that this is not efficient enough. So I'm curious to hear how maybe Kamaji is a middle ground between having one large shared management cluster and having something that Kamaji built that allows to have higher isolation without having the full overhead. Maybe Jan, if you can quickly comment on where we are there.
Sorry, I didn't expect a question to me. Actually, we still use one management because the Kamaji is used for the control planes for the workload clusters. So there's no difference on the management for the cluster stacks and cluster API itself. But of course, you can use those workload clusters as your management per customer. That's open to the operator.
Yeah, so like actually that's why I was also a bit confused here. So from my perspective, Kamaji is making it more efficient to run the control planes of the workload clusters, in theory, but like does not make any difference on the management cluster level.
Correct.
You're right, of course, Janis. And Jan, I was confused when I was asking the question.
Okay. Mark.
Do you have support for having multiple cloud environments per tenant or per customer, for example, to manage clusters in different cloud environments, or to span or to have a cluster which runs in two different cloud environments?
One cluster in two environments is not possible, but having one management cluster that goes to or is in theory connected to N providers is possible. So you, it does not matter where the management cluster runs. If I don't know, you as a user want to have multiple provider like infrastructure providers, that's possible.
Oh, that's great. Thanks.
Yeah. Christian.
Hi, Janis. Hi, Roman. Thanks for the presentation. Very cool. I have one question. Is it possible to have different Kubernetes versions, I mean workers specifically, in the same tenant cluster? Like I said a worker cluster, I think you said.
So you mean like one workload cluster running, let's say, Kubernetes 129, the other workload cluster running on Kubernetes 130?
No, in the same workload cluster.
Within the same workload cluster?
Yes, like I have like the three control planes do have like, I don't know what the versions right now are, 128.13 I think, after the upgrade. And then I have like 10 workers. 5 of them are still in 128.13 or already in 13, and the other ones are still in the 128.11 or 127.
I mean, that's going to happen automatically if you update the cluster from one version to another. But like, maybe what is your use case? Like, do you want to have that actively?
Actually, a customer had the use case. So he has a cluster where that is like the case. So what we did is like custom worker configs as you wish, with like dependency on the version, and the upgrade is taking care of that worker config, so it doesn't update beyond a specific point because the use case is like that.
That's surely not the default use case. I don't know, Roman, do you have an idea spontaneously how you would handle that?
Yeah, of course. So basically, the cluster stack, which I used in the demo, uses only one node image, also for control plane nodes and also for worker nodes. But you can develop, or some developer can create the cluster stack in the way that it is possible to have multiple versions in your Kubernetes. Yeah, it's totally possible.
Okay, great. Thank you.
Yeah. So essentially, you have the one cluster object, and this one cluster object, you can have multiple different kind of types of machines that you reference to, and then you say, of this type, I want to have like 5 servers, or nodes of this type, I want to have 10.
Saw that in the flavors, but I didn't saw a version variable there. So that's why I asked, because I saw you have different kind of workers with different flavors, which is already good and needed. But the version was missing in the demo at least, so that's why I asked.
So it's kind of like hidden kind of behind that. So if you go a bit deeper into the objects, you would see that there's a node image that Roman mentioned that is referenced there.
Great. And if I can sneak in a follow-up question real quick, does Roman, if you are in the worker cluster, do you have access to the credentials which the OpenStack Cloud Controller Manager uses to actually spawn the instances? So can the customer abuse the credentials and like create VMs on his own thing without using the operator, just using plain the credentials on some API? So can I read it?
Right now the credentials are stored in secret. Yes, you can
in the worker tenant.
Yeah.
Okay.
But basically, when you use cluster stacks, then basically the tenant is owned by user, so he has already the credentials into his tenant. So
I think like this is all in the management cluster, if I'm not completely mistaken. And in the management cluster, that's the one that you control. So in theory, you can also like just set the permissions accordingly, and just don't show that to your users.
Basically,
I meant on the like you had two possible use cases shown, one for internal use and one for like CSP usage for end users. And my question was for the if I do the end user thing, so I deploy in my management cluster as a CSP, I deploy worker clusters for my customers in a OpenStack project, which the customer does not own because he just wants the managed Kubernetes. Does he have the access to the secret to use the OpenStack project? Besides, he should not do that because he just pays the Kubernetes.
Jan, do you want to?
Yeah, I can answer. Yeah, you're right. Actually, that's the same secret currently. In the management cluster, it's isolated by namespaces, and the same secret is then deployed to the workload cluster to manage the OCCM and also to create volumes using the Cinder CSI. But as Roman already mentioned, this is always the same project of OpenStack. That means this project belongs to the customer, and he can do what he wants or she with the project. So there's no security issue. If they want to create plain VMs with it, they can do it.
I mean, it is indeed a difference because it depends on how do you do the payment and the rating and the billing? So do you do it on the project side, or do you actually need to take care on what resources are in the project, which you have to do if he has the credentials? So that's a potential leak there.
Yeah.
And you assume that the customer does own the project in such a in this space. So that's an important notice for anyone who wants to use it, because that's not always the case, right?
Probably. I don't know.
Okay.
Pretty sure, yeah. But we decided to isolate it on project level because otherwise we should have created for every workload cluster an own namespace. That would just an overhead.
And if I can say something, so if your customer doesn't own the tenant in the OpenStack, you doesn't need to provide the kube admin config. Yeah? You can always some airbag policies include there and so on. So the customer doesn't need access into the kube system namespace, let's say, or something like that. I think so. Maybe the distribution of
Yeah, but
kube
I think you can't do it like that, because some Helm charts or other deployments actually do need access to kube system namespace and other things. So I guess the normal customer, Janis, I guess you know better than everybody else, especially better than me. But I guess if you want to consume a managed Kubernetes service, wherever you book it, you go that assumption that you have full access to the cluster, right?
Yes, in general, I would certainly agree. Yeah.
Okay,
Yeah.
but
So like one thing, Christian, is that I think we right now look at it from the cluster perspective, and there are maybe certain constraints. I think in general, especially this comes from the cluster API itself, if I'm not mistaken, that use the Cloud Controller Manager and that require the secret to be in the workload cluster, or like this access to your infrastructure. But like one thing that you can think about in general is to maybe not give the people this kind of access that I described, in the sense that one customer gets one namespace. You could instead, for example, write a backend, like a platform, whatever, and hide that from the people. So if you hide that access so that people never directly access the management cluster, which is like a fully valid solution as well. Of course, it creates overhead that you need to do this backend. But like then you could obviously kind of do any pattern that you want, and that might be kind of more suitable to like manage kind of one cluster and one OpenStack, like piece of OpenStack infrastructure.
cool. Thank you for the answer.
But I think that's a very good point, especially since we are in the operations meeting here. And for the people, because I don't know, or I'm rather sure that not everyone actually uses OpenStack here, this was kind of a question about how you can, like, if you have an existing OpenStack infrastructure and want to use that, like as a managed Kubernetes, or make a managed Kubernetes on top, then how you manage exactly kind of one Kubernetes cluster and like a certain piece of OpenStack infrastructure. Just to sum it up. Quote.
Yeah, I mean, just following on onto this discussion, I think the assumption indeed was that the customer owns the project, and that way we do not have to have any security concerns about the secrets. I mean, the secrets are needed if you want the OpenStack Cloud Controller Manager being able to build load balancers for you, or if you want the Cinder CSI to build volumes for you. I guess you have a different model in mind, Christian, where you would basically have many clusters inside the same OpenStack project. I don't think we have fully thought through that model. In general, I mean, if you think about security, I would want to avoid that. But there may be use cases that are valid, right? So let's look at them together. I think we are almost out of time. If there's one last question, we can still take it. The recording, by the way, is still running. Normally in the open operations meetups, we stop at some point to have an open discussion also beyond what the topic was about. We've had a good discussion thus far on topic, so I kept the recording running. Any last questions? Yeah.
Sorry, if there's no question, then I would actually do one comment here, just to kind of sum it up what this framework is used for. So keep in mind that this is actually a framework. So it has certain tools that really improve operations if you want to build a Kubernetes platform, especially on top of Cluster API. However, it still requires a lot of work. So you have to still manage your cluster configuration and all of that. Like maybe you can manage it together with others within the SCS context. Maybe you want to do it alone. But I just wanted to kind of highlight the fact that this is a framework. You can use it for lots of use cases. It's very flexible in that regard. But it is not a solution where you just get something like this and then, I don't know, you have your managed Kubernetes running. Yeah, so just to stress that and to kind of highlight the context of this cluster stack framework.
Yes, thanks for the summary and also the bigger picture here, Yanis. I will stop the recording now. Here we go.